Okay, so we'll start out with kind of what to expect. There are some multiple choice questions and there are some problems. Okay, the problems are worth far more than the multiple choice and they'll take more time. So what part should you do first? Absolutely, you should do the written response first. Guys, you don't necessarily have to do them in order. Okay, and in fact, I don't recommend that you do. All right, my recommendation to you is read the test through quickly and rank the questions. Okay, rank them in this order. I absolutely 100% know how to do this question. Okay, do that one first. Okay, the question is like, oh, I don't know, I wasn't really good at that, I'm not really confident in that. Do that one last. All right, chances are that as you do the other questions, they'll remind you of a few things to do the question you weren't as confident about. And secondly, doing the questions you know you can do first gives you confidence instead of knocking you down first. Okay, there's nothing worse than looking at a question going, oh crap, I don't know how to do that, and then sitting there stewing over it and accomplishing nothing for 10 minutes. Okay, do the questions you're sure about first. Get them done, get them out of the way, okay, and that helps you to use your time effectively. I see that happen so often, guys, where people just sit and stare at a question they can't do and then run out of time to do the ones they could have done. So make sure you do the questions you're sure about first. Okay, get them done. Okay, they make you feel good about yourself. Okay, then you can approach the other questions after that. All right. First thing that we covered, okay, we reviewed scalar versus vector quantities. There could be like a multiple choice question, you know, like which of the following is a scalar quantity or which of the following is a vector quantity, but I wouldn't expect something that simple to be a very big part of the test. What's more important about scalar versus vector quantities is remembering which ones are which when you're asked to do a problem. For example, if you were to get an acceleration problem that asked you to calculate the final velocity, will that require a vector? It will. You'd be surprised how often people forget that kind of stuff. Okay, they get done a whole acceleration problem and it's about, you know, either maybe the final answer is acceleration, they don't put a vector on it. Acceleration is a vector quantity. Okay, so that's kind of the spot where you really need to know which ones are scalar, which ones are vector, so we remember to put vectors on or to solve it using a vector method. Okay. So our vector quantities, okay, displacement, velocity, and acceleration for this unit, so keep those in mind, okay? And for our scalar quantities, time, distance, speed, energy, although we didn't cover energy in this one, in this unit, but it is a scalar quantity, right? So keep those in mind because that'll be important. All right, that same day, okay, we covered V equals D over T, or just reviewed it, okay, from Science 10. Remember, there's V equals D over T, that is speed, is distance over time. And there's V equals D over T with the arrows, that is velocity, is displacement over time. Right? Are there going to be any like 5-mark written response questions on V equals D over T? Absolutely not. Okay, I'm not going to waste a 5-mark question on a grade 10 formula. All right, so make sure that you still know how to use it, because there could be a multiple choice question that asks you to use it, and it's part of projectile motion. It could be also part of a boat question, right? So it's something that comes up, it's something you have to use, right? But it's not something I'm going to dedicate an entire written response problem to. Okay. All right, second thing we covered, graphing. There's quite a bit of graphing on the unit exam. Okay, what 2 graphs did we go over? Position versus time and velocity versus time. Expect to see both in both sections of the test. There's a couple of multiple choice questions to do with graphing, and there are 2 questions in the written response to do with graphing. That would seem to indicate one position versus time and one velocity versus time graph. If on a graph you get the equation on the graph, should you use it to do all your calculating for that question? I would. Okay. If it's just a simple line graph and the equation is given to you, I would use the equation, especially if the problem goes like this. In bold-faced, italicized, underlined print, using the graphing equation, solve for this. You should probably do it that way. I'm just putting that out there because I see that happen all the time. Okay, I try to make it abundantly clear. This is how I want you to solve the problem. Then people do it a different way. Okay, guys, I know that there might be more than one way. Like let's say using a position versus time graph to solve for velocity. But if it says using the graphing equation or using the graph solve for this, use the graph. I'm trying to test whether you can do that or not. Okay, that's what that question is asking. Everybody follow? Okay. Position versus time, okay? And then remember a couple of things here, guys. Okay, use the graphing equation. So if we've got, a velocity versus time graph, so that's the one here on the left. Okay, so I've got that velocity versus time graph, and it asks me calculate the displacement. All right, how do I do that? How do I calculate displacement on that graph? Right, calculate the area under the line. Now, if they gave you the equation, okay, that means you need to use the equation to find those numbers, like this is B. All right, and maybe the whole thing runs for 10 seconds, so you would know X. Well, you'd have to calculate what Y is, so you'd know the height of the triangle, okay, things like that. So make sure that when you're given that graphing equation, you use it to do everything possible on that question, okay? If you're given a graph that's got multiple parts, so maybe it goes like this, okay, well then, you don't use the graphing equation for that because it won't even be on the graph, okay? You'll have to find other ways like total displacement over total time or something like that, all right? But there's nothing on the test to do with graphing that we haven't done multiple times before, including your 2 labs. Okay, I will be asking you on the test to do exactly the same things that I asked you to do on the labs. So it might be a good idea to go over those 2 labs. Okay. All right, so we got position versus time, velocity versus time. Okay. Other big thing, make sure you look at what kind of graph it is. Okay, I'll boldface italicize that and I'll have velocity versus time on the graph, but make sure you're using the kind of graph you think you're using. Okay, that's like the second most common mistake is, I ask someone to calculate total displacement from a position time graph and they calculate the area. Okay, that's not going to get you displacement. I don't even know what that gets. Meters, seconds. I don't know what those are. You don't want that. Okay, don't solve for that. Make sure you look at the graph type before you do it. All right, after we talked about graphing, then we went into acceleration, problem solving. There's 2 acceleration problems, and it's a big part of projectile motion, so we need to be able to manipulate our acceleration formulas from our formula sheet. Okay, and there could be a couple of like simple ones, simple questions / problems in the multiple choice about acceleration. Tanner, question? Yeah, that was for this graph here on the left, right? I made it up. Just, yeah, because I just hand drew the graph, so I made it up. But obviously on the test, it'll be like a Google Sheets graph that would have, it'd be valid in that case. Okay, and then vector addition. And there's a vector addition problem. And I've told you lots of times in class, okay, that it's going to be one vector that's either vertical or horizontal and one that is angled. Find the vector components, solve for the resultants, okay? Nothing you haven't done before. Just, again, make sure you've practiced your vector addition so that you can move through that question efficiently. All right? If it gobbles up a bunch of your time, okay, that's not going to be good for you. All right, so we got to remember a few things. We add vectors tail to head. Or if you're using the separate triangles, using separate triangles, although you have one vector that's going to be straight. So I don't know if separate triangles will work all that well for that. But okay, drawing them tail to head. Okay, remember boat questions are also part of vector addition. That's what this diagram over here is. Okay, that's supposed to be a river with the boat going across. Okay, we've done lots of those. Just read it carefully. Okay, so you know whether it's rowing across or going across. Because remember, the end result of those is different. Okay, if you are rowing across or aiming across, you're going to end up downstream. Okay, because if I just do this and row that way, the current will take me this way. If I want to end up going across, okay, then I aim this way, and the current pushes me so that I end up going straight across. Okay, just read the question carefully. We've done a whole bunch of questions like the one I put on there, right? So it shouldn't be too much of a problem. All right, and then projectile motion. There's one of each kind. Okay, there is a horizontally projected projectile, and there is a angled projectile as well. Okay, so once again, there's nothing on this test that you haven't seen before. Okay, every problem that I put on there, we have done a problem like it at least a half a dozen times. Okay, so nothing should surprise you on this test, right? You should be ready for everything that's on there because you've done them all before. Now, that is not to say that you can just go, oh, well, I don't have to study this week because Coderre says we've done everything on the test a half a dozen times. That is a recipe for failure. You don't want that, okay? Time's a factor, right? You have the class period to write this test. Okay, unless you have a specific allotment for more time, okay, and you know if you do, you have the class to write the test. So you need to move efficiently through the test. Okay. Oh, right, the multiple choice. Sorry, that's a note to myself. On the multiple choice, you're going to get a little paper form. Okay, it's not a Scantron form because Scantron's dead. Okay, we use the zip grade ones, right? So I can take a picture of it. When you are doing the multiple choice, use a pencil. So bring a pencil with you and use a pencil so that you can erase any incorrect answers. Because if you do this, it's just going to get marked wrong. All right, so if you've got 3 blanks, or 4 blanks, sorry, okay, and you're like, oh, it's C, and you fill in C, and they're like, oh, no, it's not, it's A. Oh, no, it's D. I see people do that all the time. They just, instead of erasing it, they put an X through it, or they did it in a pen, which you shouldn't do, and they do that. You know what my phone says when it sees that? It says this one is wrong. Okay, that's what it says. All right, it sees multiple answers for one question and just knows that it's wrong. Okay, so make sure that you erase it completely. All right, now we can obviously, if there's an issue, I can go back because the picture of your test is stored on my phone. We can always go back and review it if we have to, but that's inconvenient. So erase your answer if it's wrong. Oh, on that note, because somebody tried this last year, when we're going through the test, don't change your answers and then come up to me and go, hey, Mr. Coderre, I think your phone marked this wrong, because I'll just pull up the picture of your test and go, cheater. Okay, yeah, in front of everybody. Okay, just like I did to that kid. So don't be that kid. Well, I wasn't born yesterday. I was born a long time ago, so I'm really old. Okay, so just make sure you don't try that one on me. All right, I will take, oh, sorry, let's, details about the test here. So, give me a sec here, guys. All right, so we have 17 multiple choice questions. And there are 7 problems. So 17 multiple choice and 7 problems. Okay, there are 48 marks in the written. So the whole test is out of 65. Okay, I have put all the formulas you need on the front page of the test. You may not use your formula sheet on the test because I don't know how much stuff you've written on it and it takes too long to check everybody's. So make sure that you do not have your formula sheet out. Okay, so in the written response, horizontally projected projectile motion problem, angled projectile motion problem, vector addition question, acceleration question, graphing question, vector addition question, graphing question, and that's it. Okay. Now, things you do need to bring for the test. Okay, you do need a calculator. You can't use your phone as a calculator on this exam. On the day of the exam, okay, I will call you over to the table and you will bring with you your phone and if you have a smartwatch, that as well. Okay, both of them in the off condition. Okay, they must be completely powered down, not silenced. Okay, powered down completely. And you will have to show me that it is powered down completely and you'll put it in the blue bin over there. At that point, I will give you your unit exam, which will consist of one kind of booklet, okay, that has the questions and the multiple choice questions in, and the multiple choice answer form. Okay, then you'll go back to your desk and you can get started. All right, so I'll call everybody over, okay, and that's how that'll work. Make sure you bring your phone with you, okay, and any smartwatches that can communicate, okay, have to be put in there as well. All right, might just be a good idea to leave your smartwatch in your locker or something, okay, just so that you don't have it with you. All right, because it's really, really awkward for me if I catch you using your smartwatch or phone during a test. Awkward for me and very tragic for you. Because if I catch you doing that, you're cheating and you get a 0. And I've seen that happen on a diploma exam. And that was back when they were worth 50%, not 30. That is an automatic and epic failure. Okay, so you don't want that. Okay, I don't want that for you. Okay, so just make sure that you don't have your phone or your smartwatch or anything like that. Okay, with you while the test is going on. All right, I'll take questions. What have we got? What do we need to go over again or see demonstrated? The boat question. Okay. All righty. Okay, so I know sometimes there's confusion, again, with that whole, is he rowing across or going across thing? When you read the question, what it asks for is also an indicator of what type of question it is. Okay, a question where you end up going straight across is not going to ask you how far downstream you end up. Agreed? Because what would the answer be? 0, right? Because you're going to end up going straight across. So always kind of look at what the question's asking. That can also be an additional hint as to what kind of question it is. Obviously, this is one where we are rowing across and we are going to be carried downstream by the current, okay, while we are doing that. So, oh, I forgot to say how wide across the river was. Let's say the river is 100 meters across. I should have put that in the writing, but I didn't. It's here now. Okay, 100 meters across. You are rowing at 3.5 meters per second. And the river current is 1.2 meters per second. So tail to head, like we do with all vectors. All right, so we're looking for the resultant velocity. We did have a couple of questions last week where it asked for the angle to be measured from shore. Okay, so when I draw this one out, I won't be getting that angle, right? I would need to find the complementary angle for that. All right, so the first part of this is find the resultant velocity. Well, the resultant velocity is this line right here. Okay, and since velocity is a vector quantity, I will also need to find the angle. Okay, so how do I find r? Well, I find r using Pythagorean theorem, or at least I find r's magnitude using Pythagorean theorem. So that'll be 3.5 squared plus 1.2 squared. Okay. Okay, so we're looking at 3.7 meters per second. And then I need to find the angle. All right, so the angle will be 10 to the minus 1 of 1.2 divided by 3.5. Okay, so we're looking at 18.9. Actually, we only have two significant figures here, so we'll say 19 degrees. Okay, we'll say from straight across, or downstream, actually, would probably be better. 19 degrees downstream. Okay, had it asked for it from the shore, then I would have found the other angle, which would be 71 degrees from shore. Okay. All right, questions on that first part?
Do you not need a how far?
That's my second part. Yeah, part B is asking how far downstream do I end up. Yeah, okay. All right, so for part B, if I'm gonna figure out how far downstream we are, I need to know how long it takes me to get across. Agreed? Okay, which velocity do I use? Do I use the 3.7 or do I use the 3.5? I use the 3.5 because it points across, as does this 100 meters. Okay, I can't use the resultant because it would be longer than 100 meters. Okay, it doesn't point in the same direction as this 100 meters. It's straight across, so is the 3.5. So if I'm going to find the time, I manipulate v equals d over t. Okay, t equals d over v. That'll be 100 meters divided by 3.5 meters per second. All right, so we're looking at 28.5 or 28.6 seconds. We'll keep all those decimals for now. Okay, so now that I know that, how do I figure out how far downstream I go? I flip the formula back. Yeah, okay, so I solve for d, but which v do I use now? Right, I'm going to be in the water for 28.5 seconds. Okay, because that's how long it takes me to get across. But the whole time, I'm also moving downstream at 1.2 meters per second, right? These two things are happening at the same time. So I'm going to solve for my distance downstream by taking the speed down, or the velocity downstream, 1.2, and multiplying it by the time I just calculated, 28.5. Okay, so when we do that, okay, times 1.2, all right, I'm going to end up 34 meters downstream to two significant figures. All right, done a whole bunch of questions like that in class 10.
For a question like that, can you just change the 3.5 into 100 and use the
How can I change the 3.5 into 100? Oh, okay, you're saying make this line here, like do another calculation? So in other words, I know that the green side's 100 and find this. You can, but it's more work. It's going to take you longer, right? Because you have to calculate another number and then do the same calculations we're doing with that new number, which takes more time and increases the chance of making a mistake. I would go with the numbers given because it's less work and less likely to make a mistake. You can do it that way. I'm not saying you can't. I just think it takes longer because it's an extra step. All right. So the other type of boat question. Do we want to go over the other type? Okay. So we got this problem. River's 100 meters across. It's flowing at 1.5 meters per second. I can row at 4 meters per second, but I want to end up straight across the river from my starting point. So my starting point will be right here. Okay, so I know that the river flows at 1.5 meters per second. I know that I want my resultant to be straight across the river. And I know that the river is 100 meters wide. Okay, I can row at 4 meters per second. I want to find my heading first. So what do I have to do? Where does my heading go? Because I just drew these two vectors tail or head to head. Why did I do that? Go on. Why did I draw them head to head? Yeah, exactly. Okay, so this is my resultant. Okay, it's got to touch the head of one. Okay, because it's going to connect the beginning and the end. So that means that my rowing speed is the other vector that goes right here. Okay, it's 4.0 meters per second, but it's the hypotenuse. The resultant is not. Okay, the resultant is the adjacent side to the angle, okay, that I'm going to have to find, which is this one. Okay, so I need to find that angle first. I have the hypotenuse and I have the opposite side. What trig function will help me find that angle? Sine. Okay, so I'm going to go that the sine to the -1 of the opposite side, 1.5, over my rowing speed, 4.0, the hypotenuse, will give me that angle. Okay, so it's 22 degrees upstream. All right, 22 degrees upstream is my rowing angle or my heading. The second part of this question wanted to know how long it'll take me to get across. So I already know it's 100 meters across, but I don't know how fast I'm going across. How do I find that? Where is how fast I'm going across? Which one of those lines is how fast I'm going across? The resultant, yeah, R, the red one. Right, so if I'm going to find that, okay, there's two ways I could do that. I could use Pythagoras and I could go this squared minus this squared gives me R squared, or I could just use the hypotenuse and the angle I just calculated and calculate the adjacent side. Okay, that's the way I'm going to do it. I'm going to go cos of 22 degrees times 4 and just get that side. All right, so that side's 3.708 meters per second. All right, that points straight across, as does the 100 meters. So I can easily calculate now how long it takes me to get across using the speed across and the distance across. Okay, so T equals D over V, 100 over 3.708, and I'll have my time to get across. All right, it's going to take 27 seconds to get across because I only have two significant figures. All right, so those are your two kinds of boat questions that you could encounter. Okay, what else? Josh? Which kind? Oh, thrown horizontally. Okay. Okay, so we're going to say that we have a 200-meter cliff. It's big. It's like the Grand Canyon or something. Yes. Okay, so we have a 200-meter high cliff, and we know that the object that we throw is going to end up, let's say, 85 meters. So it'll hit the ground at the bottom of the cliff, 85 meters from the bottom of the cliff. I want to know how fast it was thrown. Okay, I'll give you a couple minutes to see if you can try that one. Okay, let's walk through it. So as Ed pointed out, if I don't remember that my initial vertical velocity for a projectile thrown horizontally is 0, I can't even start this question because I don't have enough information then, right? So as with all projectile motion problems, we want to break this up into vertical and horizontal components, right? So vertically speaking, the displacement is going to be 200 meters down. The acceleration is going to be 9.81 meters per second squared, down. And our initial velocity is 0 meters per second. From a horizontal perspective, I know only one thing, and that is that the horizontal displacement is going to be 85 meters. Okay, so I'm trying to find the horizontal velocity. Okay, it was thrown horizontally, so I'm trying to find that. Right, that means I need displacement, which I have, and time, which I don't. Right, can I find the time with the vertical part? Is there a formula I can use? Okay. It's the same one we've used basically every time we've done one of these. Displacement is VI times T plus 1/2 AT squared. Since VI is 0, I don't need that part of it. Okay, it's just D equals 1/2 AT squared. All right, so T will be the square root of D over half of A. So that'll be 200 meters divided by 1/2 times 9.81. All right, so this thing's going to be falling for 6.385 seconds. All right, so then I can go over here because time is the one thing that can come across. 85 divided by 6.835. Okay, and we will have our horizontal velocity. Okay, so it was thrown at 13 meters per second. Okay, ringing a bell. It can be, but then that has to be negative too. I just made them both down and I made down positive. There was no change in direction, so it wasn't necessary, right? Which is why I didn't do it. In a projected at an angle, you do have to make it negative because it starts moving up and comes back, coming down. Yeah. Well, we would say it's not really one where we could, I would probably ask for what speed was it thrown at? I mean, we don't really know what direction because the question never specified. We could say horizontally. That would be about all we could say. Okay. Go on. For the angle ones? No, not on the test. There are some like that on your worksheet. But no, I won't ask that on the test. I just want to know that you know the general principles as opposed to do the hardest one I can think of. Okay. Yep. Okay. And so guys, just so you understand, my philosophy on exams is that an exam should test that you know the material I've taught you, not can you extrapolate to the hardest question I can think up. Okay. I might do that on an assignment, okay, where you got more time's not a factor and you can talk to your friends and stuff like that. I might ask you a tougher one on an assignment, but on a test, I will ask questions that we have done. Okay, they will be like the ones we have done in class. There will not be any tricks. Okay, there will not be anything that is, oh yeah, just here's something I kind of touched on once, and then here's a curveball to throw at you. Okay, I'm not going to do that. I don't think that the test is the place for the hardest question I can think up. Okay, other people might disagree with me. I like to think of them as wrong. Okay, but that's not what I think a test is for. Okay, so understand that the questions that I'm giving you on your exam on Thursday, we have done all of them. Well, not those specific questions, but done ones exactly like them before. All right, what else? Tanner? Launched at an angle. Okay. Okay, so we'll have that set up. The object's going to be launched at 80 meters per second at a 20-degree angle above the horizontal. Okay, and I am going to want to know the following two things. How far horizontally and the maximum height. Okay, give you a couple minutes on that. All right, so our first part here, okay, is that we need to, as we do with all projectile motion problems, break this up into its horizontal and vertical components. Okay, because the only thing they share is time. All right, so from a vertical perspective, okay, this side of our projected vector is the initial vertical velocity. And this side here is our horizontal velocity, okay, because they are the parts, the vertical and horizontal, of the projected velocity of the object. Okay, everybody with me so far? All right, so if I'm going to calculate the initial vertical velocity, it is opposite to the 20-degree angle. So I'll take the sine of 20 and multiply that by 80 meters per second. And that'll give me my initial vertical velocity. Okay, so we've got sine of 20 times 80. All right, so we're looking at 27.36 meters per second, and that's up, so I'm going to make it positive. My acceleration, vertically speaking, is negative 9.81 meters per second squared, negative because it's down. Now, what do I have to remember about the initial and final velocities if this is on a level surface? When it hits the ground over there, VF will be? It'll be the same as the initial. It'll be zero after it hits the ground. The instant it hits, it will be the same as it was, right? We throw something up in the air, when it comes back to us, it's moving the same speed it was when we threw it, right? Because it travels the same distance up and down, same rate of acceleration up and down, so it has to be going the same speed when it comes back. All right, so VF is going to be negative 27.36 meters per second. And that's the thing we have to remember if we're going to get started on this type of question. Okay, I still have to calculate V horizontal, so I'll go over here and do that. It's the adjacent side, so that'll be the cos of 20 times 80. All right, 75.18, we'll say. Meters per second. What do I need to find next? If I'm going to find out how far it goes horizontally, what else do I need? Time. We're always looking for time. Okay? Time equals VF minus VI over A. Okay? That's the formula we have to use because that's the information we have. So that's going to mean negative 27.36 minus 27.36 divided by negative 9.81. Okay, so we're looking at 5.58 seconds as our time. Right, that I can bring over here. D equals V times T, so that'll be 75.18 times 5.58. Okay, V times T. All right, so we're looking at 420 meters. We only have two significant figures, so 4.2 times 10 to the 2 meters. Questions on that one? Now that's only the first part because the question also asked us to find the maximum height of the projectile. Okay, so maximum height occurs right here. How fast is the object going vertically at its maximum height? 0. That's the thing we have to remember in order to do this. Or we have to remember that that occurs at only halfway through the flight, so the total time would be divided by 2. Either way will work. For right now, I'm going to use this formula. Equals VI squared minus, or sorry, plus 2AD. Okay, so to get the distance, the vertical distance will be VF squared minus VI squared over 2A. Okay, so we'll have 0 minus 27.36 squared divided by 2 times negative 9.81. So 27.36161147 squared, okay, divided by 19.62. All right, so the maximum height of this thing is going to be 38 meters.
What would a question like this be?
Probably finding the total displacement on the bottom, that would include your givens, would probably be, oh, I want to say like 4 marks maybe, and then finding the maximum height might be another 3, 7 or 8 marks. You're not going to get marks for givens twice, right? You just get in the first part. Okay, what else, guys? All right, are significant digits going to be important on the test? Yes, and there's a reminder on the test about significant figures, so please make sure you keep those in mind. Okay, it sucks to get a whole question right, get everything all the way through, and then forget the sig digs at the end and lose a mark. All right, so make sure you're doing the significant digits right. And the reason, guys, we're so sticky on that is because when you write the diploma exam in Physics 30, if you don't get the significant digits right on the numerical response question, it's wrong. Okay, it's just 100% wrong because it's only out of 1 mark. It does suck. Okay, there's questions on the diploma exam. Last year or last semester, there was a set of 2 questions that required the students to read 3 pages of text. But there was a couple of pictures, but it was 3 pages of text about this experiment with a cathode ray tube. Okay, and they had to read all this stuff, and then they had to answer 1 multiple choice question and 1 numerical response question after reading all of that information. Okay, and if you didn't get the significant digits right in the numerical response, you got nothing. Okay, and there was a lot of work, not just the reading, but there was probably a good page worth of calculations and stuff to do to answer those 2 problems. And if you didn't get the sig digs right, you just got it wrong and you wasted all of that time. Okay, so sig digs are important, and that's why we harp on you now. It only costs you 1 mark out of 4 or 5 now. Okay, but on the diploma exam, it costs you everything. That's, well, in my mind, not right, but you know, I don't have any say in that. I'm just a peon. All right, then you got some time here to go over the review package, work with a friend on that stuff or whatever. Okay, but let's stay focused on preparing for the exam for the remainder of class today. And then tomorrow we're back to projectile motion again. Yes.
When you go over the second, or I guess the first part of calculating.
The first part of calculating max height? Okay, the first part of calculating maximum height is to remember that VF is 0. Okay, when something gets its maximum height, it is slowed down all the way to that point, right? And then it's going to start to fall back. So that's the first part. Okay, the second thing we have to remember is that VI doesn't change. Okay, it's still projected upwards at 27 meters per second. So then the only formula I have that has D in it and A and the 2 V's is this one. I could also use this formula as long as I remember to divide time by 2. Okay, either way will get me the right answer, but I have to remember on that one to divide the time by 2. I don't have to alter any numbers for the first formula, which is why I use it more often, okay? Because I even sometimes forget to divide the time by 2 and then I get a weird answer. Okay. And the wrong answer, most importantly. Okay, any other questions there, guys? Okay, if more come up, please ask. I'll come right back up here and do some more, okay? But we want the review to be focused on you. What are your questions? Okay, so make sure you ask if you have some.